My name is Guillaume Bichot, and I'm going to present you how to optimize ABR streaming using and relying on the server side feature that is capable of selecting the quality or the bitrate instead of the player. So let's first start with the problem we wanted to tackle with this technology. And let's start first with refreshing about ABR principles. So basically, on the left side, you have a content that is encoding in several substreams. Each substream is encoded with a different quality and therefore a bitrate. So highest is a bitrate, highest is a quality. On the right side, the player requests, all the substreams are split in the segments of equal duration, for example, 2 seconds. On the right side, the player requests segment after segments, and for each segment, it requests a particular quality, a particular bitrate, according to its bandwidth estimation, and also according to this its buffer, video buffer occupancy, right? So if the player requests the medium quality, the server returns the medium quality. If the player requests the highest quality, the server returns the highest quality, and so on. So the problematic with this way to do is there are basically two problems. One is the measurement. The measurement of the player is based on HTTP, and this is it provides a rough estimation, right? Not very accurate, and this is problematic, especially in live streaming, and even worse in low latency live streaming. So here you have the result of experiments in low latency with the -IF player. The gray area is the maximum available bandwidth, the ground truth. The green curve is the bandwidth estimated by the player. It looks strange, right? So, but that's the way it is. And the dash line, the dash curve, the blue one is the quality, the bitrate selected by the player. And you can see that it's not very accurate. And sometimes, like under the red spot, the quality selected goes beyond the maximum available throughput, which is very problematic, especially in low latency, right? It drives to QE problems, to video freezes, or lost frames, and so on. Yeah, this is due mainly to the way the bandwidth is estimated. It's estimated thanks to HTTP protocol, which which is not very accurate, right? The second problematic we wanted to address with this technology is the fact that the player is on its own, right? So player is alone trying to maximize the quality of its session and doesn't care about the rest of the world, right? The rest of this environment. And this is problematic, especially if the player has a greedy behavior, like most of the player has, especially in VOD streaming. So the ISP somehow is frustrated not to be capable of controlling this, bandwidth consumed versus QE, right? And this is the server-side segment selection provides a way to mitigate this problem. So the solution is, has been, designed 2 years ago already. And what we did is quite simple to understand. Let's go back to this ABR principle. So the player still works the same, requesting segments, but in that time, the server returns the segment of its own selection, right, of the quality corresponding to its own selection. And the server relies on the congestion control bandwidth estimation. So here, typically, we tested a lot, experimented a lot BBR. So BBR has a very fine and very accurate bandwidth estimation, and the server, thanks to this estimation, returns the segment corresponding to its own selection of quality. So if the player requests the medium quality, maybe the server will return the highest quality. And if the player requests the highest quality, maybe the server will return the lowest, right? The server controls, and the players just, tries to do his job after all, which is, getting a segment and display it as soon as possible. So with that way to do, we solve the the live latency, the live and streaming case, and in particular the low latency streaming case. So we are still in the same environment than the previous experiment with the -IF player, same player, exactly same version, same environment, and that time you can see that the bandwidth estimation is much more accurate. So the highest blue curve is the BBR one, the green one, sorry. The blue curve is our own, estimation based on BBR, and the orange dash curve is the bandwidth selected. So it works. We conducted a lot of experiment, of course, and yes, we can say that we solved our problem, our first problem. For the second one, it's very effective. Can understand that, okay, we can with S4S with server-side segment selection, we can forced and downgrade the quality at any time for any reason. So here's an example. The left side, this is a quality, optimal quality. The default one selected the default strategies where the server selects the highest quality right below the bandwidth estimation. On the right side, we have instructed the server to select one level below the optimal quality, just to economize bandwidth. For example, if you assume that your CDN is overloaded and you want to be careful, and then you can instantaneously degrade the quality and serve the quality a little bit, still ABR, but one level below the optimum, save a lot of bandwidth and save your CDN maybe, and accept new session, for example. Yeah, so that's a powerful tool for the ISP. So how does S4S works? So we have two modes of operation. First one is a transparent mode, and the transparent mode is basically transparent for the player. It relies on two features. The first one is a self-initializing segment, which is a video segment in which we prepend the init segment. This is simply like that. Most of the players support that. And the second feature that is we have to modify and update the manifest in order to encode in a URL attached with each media segment. We have a specific encoding of that URL that basically gave us all over representations URL plus their bandwidth information, which makes the server, stateless, doesn't need to, proceed with the manifest. Just have to, read the URL of the segment request, and it gets all the information it needs to do its own selection, right? The second mode of operation is called non-transparent, so it requires the players to be adapted to be modified. It's a protocol, right, based on HTTP headers, it's custom headers. And basically it authorizes an exchange of information between the server and the client and the player. The player communicates his buffer status and the supported representations, and the server communicates to the player the bandwidth his bandwidth estimations and also the representation that is currently served, which makes overall a way to enhance again the quality. So at any time the server is a master, right? At any time the server can just let the clients, the players running and keeping and getting the control of the session. And at any time it can take the hand again and just force the player with its own representation selection, right? It's a master of the game, but it can also let the player running if it's so the protocol, there is a possibility with that protocol that for the player is not obliged to support self-initializing segments. So basically the players just have to indicate in its request that it indicates, basically the list of supported representation. It just have to not indicate the path of the init segment. The server understands that it doesn't support self-initializing segment, and just in both cases, it just returns the quality that it has selected, and the player has to react accordingly, right? And if it doesn't support self-initializing segment, it has to initialize correctly its decoder using the conventional method, right? We have, of course, as I said, a way to exchange information between the server and the player. So basically, as I explained, it's about RTT bandwidth estimation from the server, and from the client, the stalling, buffer occupancy, such kind of things, and Yeah, it is basically covered by the CTA 5004 CMCD protocol that at that period was not yet ready, not published. But we are ready for, switching to this protocol as soon as it will be published. So S4S is also about the HTTP protocol, right? We started experimenting with HTTP 1.1, but thanks to this, multiple concurrent TCP connections, it was very unsteady and very complex to, to tune this the server. So that's why we decided to recommend and to require HTTP2, which is much more reliable, because there is only one TCP connection basically. So HTTP2 and beyond is what it is required for good functioning. We rely on, as I said, on a modern congestion control that is capable of estimating the bandwidth finely, correctly, and accurately. This is BBR, of course, but PCC is another way to, another congestion control that is, that is quite accurate actually. A lot of players support the S4S, this method, this way to do the transparent mode basically. For non-transparent mode, we have, we're on a POC basis, right? We have actually currently 2 POC running, and it requires, as I explained, a modification of the player. So let's have a quick reminder of about the use case that can profit from this technology. So the first is the cost, right? So we have customers that have to pay for each bit that goes over the access network, and so assuming that you have a way to control the overall bandwidth consumed, you can actuate the server and just limit the bit rate as soon as you are approaching the threshold. Another way to control to use and operate S4S is when you have control the bandwidth and you control your CDN. And you can detect that your CDN is close to be overloaded, right? So then you can just decrease the number of the bit rate and therefore limit the overload. The last one is about mobile sales. Imagine your server actually controls the video session. Most of the traffic is from your server covering one or several cells. So with that way to do, if you have a way to detect that the cells are nearly overloaded or very close to be overloaded, then you can limit the bit rates in order to accept more sessions, right? Or just to avoid this overloading. That terminates my presentation. So thank you for listening, and I'm open for questions.